Okay, let's talk about the rate of reaction. And really, what we're going to talk about is what can speed up or slow down a chemical reaction. So, the first thing that we have is concentration. Yes, molarity. So, we have already talked about molarity when we made solutions. And so, one way that you can increase that concentration is by creating a higher molarity within the solution, such as a 12 molar hydrochloric acid is much stronger than a zero point 0.1 molar hydrochloric acid. It will allow for the reaction to happen at a quicker rate, and it will probably use up more of the other reactant that it's going through. And so here's what we can see. As we have a higher concentration, we are getting a higher product yield of product B versus product A. Notice the timeline. Product B is increasing, which should make sense because we're having a chemical reaction, so reactants are turning into products at a faster rate. And then we have an equal decrease of reactant A. So your higher concentration will have a higher or faster decrease of that reactant A. Some other factors are surface areas. So if we have things like a pill and you drop it into a liquid, then you have to stir and stir and stir and stir and stir. Well, it takes forever. It's because it doesn't have a high surface area. So if we would take that same pill and crush it into a powder here, it now has a greater surface area for the same reactant. And we can put it into a substance because we increase the surface area and it would dissolve much faster. This is why also when you take medications, there's a powdery substance inside those capsules. Once that gel capsule dissolves, all of that powder is then absorbed by your body and the reaction happens much faster. So that's how we get that. Also with those gel capsules, some of them dissolve in their time release. So they'll just let small amounts of that antibiotic or medication or painkiller out over a long period of time. That's how they can release. You can have the effects of like a 12-hour painkiller. It's because they have these gel capsids that are set to release at specific times. And that's nanotechnology doing that. The other one is high temperatures. So the higher the temperature, the faster the reaction. Doesn't necessarily mean you're getting more product. You're just having that reaction happen faster, and that's because the particles are colliding with each other quicker, and because they're smashing into each other, they're passing their kinetic energy, and as everybody has a lot of kinetic energy, it's like giving pixie sticks to a kindergarten room. Everybody is crazy and running around, and therefore the greater forces that they kind of submit to making those products. So you can get them to do things a little bit easier when they have a little bit more energy and crashing into things already. The other thing that we have is catalysts. I know, flashbacks to biology right now, but a catalyst doesn't have to be a protein. This is any substance that increases a chemical reaction without being consumed. So in our human body and in biology last year, we talked about proteins all the time. But basically, a catalyst is anything that's lowering the activation energy. A catalyst doesn't participate in the chemical reaction. It just lowers the energy needed to start the chemical reaction, and it's not in the product. The catalyst can be collected afterwards and can be reused for most cases. It just lowers the activation energy, which means the reaction can happen quicker. We did this last year at the Potato Enzyme Lab. These are all things that can really speed up chemical reactions. Concentration, temperature, surface area, and the use of a catalyst. That's the last section for today.